So let's continue. So chemical machining can affect the mechanical properties of the machine part when the surface layer have different mechanical properties from those in the base layer. So removal of such layer result in a change in average mechanical properties of the finished parts. So what it says is this. So if your workpiece has some surface properties that's different compared to the bulk material because of the surface treatment, something like that, then chemical machining will remove that particular surface. So because of that, then basically the mechanical property of the workpiece will be changed. So you have to be careful on that. So if you want to use a chemical machining process and you want to do surface treatment, do the chemical machining first before it's being treated, right? For example, so in regards of a surface conditions such as the titanium oxide layer, alpha case, so decarburized layer, recast layer can easily removed by chemical machining, resulting in improvement of properties of the finished part. So if you have a workpiece material that has a surface property which is not desirable because of the previous process. For example, on the oxide layer of titanium because of alpha K because of alpha K. So if you have a titanium oxide layer, then titanium oxide layer is very brittle and is completely different compared to the titanium bulk material properties. So you can remove the titanium oxide layers using this particular process. So if you have aluminum workpiece materials and as oxide layer on the outer surface, usually if you want to use it as a finished product, you want to remove the first layer. But if you use this particular process, chemical machining process, then you don't have to remove that layer because the process itself, the chemical etching process, will remove that particular layer. Or in the case of carburized layer for, let's say, for example, for steel. So steel, if you make a steel using forging, rolling, sometimes you have a carburized layer. Carburized layer means that carbon being dissipated out from that particular layer. So the properties of that particular material, let's say for example, if you have steel, if on the layer itself, because of the forging process, because of whatever process is being carburized, meaning that the carbon atoms is dissipated out from that particular layer, then the properties will not be as good as the bulk material properties. So using this particular process, it will remove that particular layer. Or recast structure. So recast structure can easily be removed for this particular process. So recast structure. So many other process that we learned so far has some recast layer. For example, EDM process. So EDM process is basically, if you remember, removal of the materials due to molten of melting and also the pricing of material. So because of that, then it will have some EDM. If you run process, you, if you make something using EDM process, it will have a recast layer. So if you have that particular workpiece material and you want to finish it up with electroplating process, then it can remove that recast layer. Some loss of fatigue properties have been reported after CHM of aluminium, however, short pinning or great plastic can restore it. So sometimes if you have aluminium, if aluminium goes through this particular process, chemical etching process, then basically it will lose some of the fatigue properties, because if you make aluminium using rolling process, then basically you have a hard case hardening on that particular workpiece. So case hardening is good with regards to fatigue. So if you use that particular workpiece that went to surface hardening or case hardening of aluminium as a workpiece material, then chemical etching will remove that particular surface. So you're going to lose that properties. But you can restore that particular properties using pinning or grade blasting process. So pinning and grade blasting process is a process for case hardening. So those are the things that some of the things that you need to watch out for with regards to accuracy and surface finish when you want to do machining using using chemical machining process. Some advantages of CHM. So the first thing is weight reduction is possible on complex contour that are difficult to machine using conventional methods. Simultaneously removal from all surface, improve productivity and improvement and reducing warping, no burr form, no stress induced in the workpiece, which minimize the part distortion, so on and so forth. So basically, one of the advantage of chemical machining is it can do weight reductions on the complex contour. So if you look at this particular image, right? So if the space like this, and if you want to do weight reductions on that particular those kind of surface, then basically you can make feature on surface as such. And basically, if you want to do this using other process, it's going to take some effort, some money, some time. But using chemical machining, you don't need to do that because it's a simultaneous material removal process will happen. So what you do is basically you just to use you put the mask on area that you don't want to be etched, and then you etch it. Once you submerge everything inside the etchant solutions, then basically it will etch everything simultaneously. And uh, and uh, and there is no burr formations in this particular process, and no stress induced on the workpiece. So if there's no stress induced on the workpiece, meaning that there's no internal stress, there's no warpage, so on and so forth. So there's no stress induced on it because it's chemical process. You are not subjecting the materials with the forces, with the stress, so that that's the reason why you don't have any internal stress. But if you use let's say for example heating process or use a mechanical process, then you have induced internal stress inside the materials. Then you start to have warpage, distortion, so on and so forth. Continuous taper on contour section is achievable. So if you want to have a continuous taper, then you can do that with this process. And I mean, you have to live with the actually continuous taper for parts machine using this particular process. Any questions? Some other advantages: capital costs low compared to other processes. Design changes can be implemented quickly because the only thing that you change is the mask. Basically, is the mask. So you can, if you change the mask, and mask is very easy to change because if you apply mask using dipping, so on and so forth, you scribe it. So in order for you to scribe it, you need to have a pattern. So easy to make. Less skilled work operator is needed, so you don't need a skilled worker. So the only skill thing that you need to do is making the mask or inscribe the mask. That's about it. Tooling costs are minor. Good surface quality in addition to the absence of burrs. So basically, surface quality is relatively good, and you don't have burr, so you don't have finishing operations to do on your parts. Multiple part having fine details can machine in a gang method, so you can make multiple product all together at one go. Decorative finish and extensive thin web areas are possible. There are low scrap rate, less than scrap rate is quite low, and you can do thin web finishing process. Limitation. So some of the limitations about this particular process on the shallow cuts are practical. Only shallow cuts practical up to 12.27 millimeter on the sheet and plate. on exclusions 3.83 and on the forging 6.39. If not, basically the the uh, the the overcut is going to be quite substantial for you to manage, and also the accuracy of the depth cannot be controlled that well. Another limitations, handling and disposal of chemicals, troublesome. So there are a lot of environmental issues and regulations that you need to make sure that you obey. Hand masking, scribing, stripping can be time consuming, repetitive, and tedious. So if you do scribing manually, then this can be quite repetitive. Surface impression are reproduced in machine part, as I mentioned just now. If the initial workpiece has surface imperfections on it, the surface imperfections will be replicated to a certain extent on the finished product. Okay? So you cannot get rid of that. Metallurgical homogeneous surface are required for best results. So you need to make sure that if you want to have a good result and uniform result throughout the surface of the workpiece that you machine using this process, metallurgical homogeneous is very important. So if your workpiece has some metallurgical differences on its surface, for example, if you have one surface that's joined together with a weld, when you machine it, the weld area metallurgical property will not be the same as the rest of the area. So you get deep narrow cut are difficult to produce. So if you want to make a deep and narrow cut, it can be hard to produce because during etching, you're etching in 3D, 3 dimensions, X, Y, and Z. So you cannot just etch in Z directions. So you cannot get a just narrow cut. That's why you have that undercut. That's why that uh, you have to factor in the undercut for this particular process. Any questions? The depth of the cut. So it's not adjustable. You cannot modify it. It's fixed by the depth of the cut. Depending on the depth of the cut, the deeper it is, the bigger the radii going to be. Porous casting yields uneven edge surface. So if you have a porous casting, so if your workpiece is made using casting process, basically you're going to have a porous surface. So if you have a porous surface, you're going to have an uneven edge surface because you have air bubble porosity inside the workpiece. Same with the welded area. If you have a workpiece that has weld area, then basically it will be etched at the rates differ from its base material. So you're going to have a different depth of etch uh, 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 different material. Example is if you have in the absence of residual stress on the chemically machined surface can produce unfavorable fatigue strength compared to with the process of the induced compressive stress. Again, examples on aluminum just now, right? So if you have residual stress or internal stress due to some other process on the surface of the workpiece, right? So once you machine it, the surface will be removed, then basically that residual stress will not be there anymore. So then it will reduce the fatigue resistance of that particular fatigue strength of that particular material. Another limitations, hydrogen pickup and intergranular attack problem with some materials. So some materials where you have for example alloy, so you have intergranular attack. What it does is basically at the intergranular uh, portion grain, then basically etching will get very deep inside it. So because of that, then you have hydrogen pickup, so on and so forth, that going to weaken that particular area. Straightness of the wall is subject to fillet, so it's very hard for you to get a straight wall. Scribing accuracy limited, the complex design become expensive. Steep taper are not practical, so you won't be able to do a steep taper because it's just not practical, because it's eating up the X, Y, and Z direction. This is examples of titanium parts that has been descaled and being checked to verify scale removal. So etching process, this particular process is one of the process to do descaling for titanium parts. If not, they're going to have titanium oxide layer on the surface, which is very brittle. So it's not good for the parts. Some applications of this particular machining process. All of the common metals can be chemical emissions. So basically, common metals, wide variety of metals can be chemical emissions, and also exotic metals, for example, titanium, zirconium, molybdenum, and as well as some non-metallic metals. So the range of the application for this chemical machining is quite large. In here it says that from large aluminum airplane wing parts to minute integrated circuit chips. So even if you want to make MEMS, you can use this particular process for them. Practical depth of cut range from 2.54 to 12.27. So you cannot go too deep. The reason we cannot go too deep, as mentioned just now, it's going to be hard for you to control the accuracy of the depth itself. Shallow cuts are large thin sheet of the most popular application. So most popular applications basically large parts, thin, shallow depth. For example, for this weight reduction for the aerospace component. Multiple design can be machined from the same sheet at the same time. So this is another advantage and also application. So if you want, if you have a big sheet of metal workpiece, then you can make many parts on the same sheet of metal. What you do is just change the pattern of the mask. That's about it. Chemical machining is used to thin out wall, webs, ribs parts that can be produced by forging, casting, or sheet metal forming. So basically, another applications of CHM is actually to thin out walls, webs, and ribs of parts that has been produced using forging, casting, or sheet metal forming. Usually, when you use this mechanical means of making parts, you cannot make the parts too thin because it will get distorted. But due to some weight reductions requirement, then you can thin out the walls, the webs, so on and so forth using chemical machining. So this is examples of it. So you make, if let's say for example, if this part is made using forge, so you can make it too thin because of the mechanical handling of it, so on and so forth. But you can reduce the thickness. So the dotted line is the initial thickness. The solid line is the post chemical machining process thickness. So you can thin, you can do the thinning of the parts using chemical machining process. And basically, if you remember, the depth of the machining is a function, mainly the function of time. So you can thin as much as possible, and there is no there is no stress induced on the parts. For example, this is another examples of thinning. So this is initial shape, a form shape. You can thin it to this. So basically, this can be done maybe using deep drawing process. So deep drawing process, you cannot get the wall thickness to be too thin. But if the finished product requires it to have a, a thin wall, then you can submerge the whole thing inside the chemical, etching chemical, etchant chemical. So you can thin the wall. This is another example, machine surface, and you can thin it by chemical machining process. So this is another examples of most commonly used applications of this particular process. Any questions? Further process applications related to improving surface characteristics including the following. So some other application that actually improve the surface characteristics. Eliminations of alpha case from titanium forging and superplastic deformed parts. So this is, we discussed this just now. On titanium, if it's made using forging process, then you have titanium oxide on the surface. So you have alpha case on the surface, so it can be removed using this particular process. Elimination of the carburized layer of low alloy steel forging. So I mentioned it just now. So during forging process, then basically the surface will be decarburized. Means that the carbon atoms will leave the material, will dissipate from that particular layer. So that the layer of the steel alloy, forged steel alloy, will not be that good. So by etching it, you're actually removing that unwanted layer. Elimination of the recast layer from parts machined by EDM. Again, EDM process, you have a recast layer, so you can remove the layer using this process. Removal of sharp burrs from conventional machine parts of complex shape, so you can deburr using this particular process. So remove thin surface from forging, casting prior to penetrations inspection below the surface required for detection of hidden defect. So this is inspection requirements. Sometimes when you have a forging process on critical parts, so if you want to see whether there's a crack or not, so you need to make, for example, die penetration test. So in order for you to die penetration test, then you want to remove the thin surface of the forged or casted product first before you apply the die. So this process can do that, can perform that particular process, removal of thin surface layer from forging and casting. So basically, those are the materials that need to be covered in this particular topic. So I'm open for question and answer. Anybody? You can unmute yourself and ask questions, or you can write using chat room. No? No questions? Okay. So question is, what is the gang methods you mentioned just now? So gang methods means that when you process parts, what do you call it, in bulk, then you call it gang methods. They call it gang methods. For example, in the illustration, that one of the illustration that we have. So this is processing parts in singular methods, one at a time, right? So So this is, when you process parts, multiple parts at one go, then this is called gang. So it's just a term being used in manufacturing. Whenever you process parts in bulk, in multiple parts at the same time, you say that you're doing a gang method. Any other questions? Okay, while waiting for your questions, so I posted what do you call it? The quiz. So please attempt the quiz. So before I think I give it like 2 days, 1 or 2 days for you to attempt, because the ULEN is not stable right now. So make sure that you attend that, and I'm going to use the attempt, whoever attempt that a particular quiz as the attendance for the ULEN session, ELEN.
Okay, sir.
So basically, I just want to share with you in terms of the concept about this particular e-learning. Uh, so um, so for this e-learning to be effective, you have to read first. And the sessions that we are doing, live sessions that we're doing this, basically is a supplementary only, because based on feedback by the university, not every student has access to internet actually to join the live e-learning sessions like this. So I urge you guys to actually read the materials and have questions and clarifications to be asked during this particular session. And make sure that you watch the video on your own time, and you can ask what you've seen in the video during these sessions also. So there are a few feedback that I got from you uh, based on the feedback request last week. One of it is basically uh, student wants more question and answer sessions. So that's why I'm extended these sessions a bit more. Second, basically they want some assignment. So the assignment is basically the quiz. If you think the quiz is not sufficient for you for the assignment, let me know. Other things basically what I think those are the two main things that I pick up from the feedback from you guys. Okay, any questions? Ada? No questions. By the way, the test and also the final exam will be open book test and final exam. So if it's open book, usually the questions will be a bit more in depth, and you need to source information other than what's given to you during lecture. But the fundamental information's supposed to be delivered during the lecture itself. However, to answer those open book questions, then it requires you to apply the fundamental knowledge to the questions. So time will be longer compared to regular exams. Yeah? So one more questions on. Okay, the question is no questions, sir. So so if there's no questions, then I'm going to end these sessions now. Again, please do answer the quiz and watch the video. And what I'm going to do, I'm going to have another feedback sessions posted for next week, so on and so forth. Please remember our next meeting, our next class will be next week. I'll schedule it from 2 to 4 as our regular class schedule. Right? So kalau tak ada questions, then thank you very much. Thank you very much, and selamat berbuka to those yang puasa. Assalamualaikum warahmatullahi wabarakatuh. Thank you.